Hi, welcome back students. We are discussing number system, right? So in a previous class we discussed exercise 1.1, right? So today we will go to the next exercise, that is exercise 0.2. In exercise 0.2, the first question is that state whether the following statement true or false and justify your answers. So here we want to say it is a true or false, and we want to justify our answer why it is a true and why it is a false, right? The first question they given here, every irrational number is a real number. Yes, it is a true, because the real number is a combination of collection of rational and irrational numbers, right? So that's why it is a 2, since the collection of real number is made up of rational and irrational numbers. So our real number definition also says that the combination or collection of rational and irrational number is a real number. So that's why it is a first one to true. Every irrational number is a real number, right? Question is there. Second one, the every point on a number line is of the form of root m, where m is a natural number. So here they asked every point on a number line is in the form of a root m and m is a natural number. So it is a false, because the negative number cannot be expressed as the square root of the other number. So negative number we cannot be expressed as the other square root numbers, right? Otherwise another one reason is there. So in between root 2 and root 3 there are infinite many numbers are there, right? Root 2 and root 3. So there are, in between these two numbers there are infinite numbers are there. They can't be in a form of root m. They can't be in the form of root m, and m is a natural number. It means they comes in a decimals also, right? So decimal, that is not in a natural number. Is it clear? Right. So next question is, the every real number is a irrational number. Every real number is a irrational number. It is also false, because the real number is a collection of all rational and irrational numbers. But they said here every real number is an irrational number. Only they said here irrational number. No, because the real number include both rational and irrational number. The real number include both rational and irrational number. So that's why it is a false. So every real number can't be irrational number. Every real number can't be irrational number. It is a rational and irrational number. So well students, the next question is, second one is, are the square root of all positive integers irrational? They asked here, are the square root of all positive integers are irrational? No, they are rational, right? If not, give an example of the roots of a numbers that rational numbers. So here we want to give an example, right? So they are not a rational, because the square root of root 4 is equal to 2. 2 is a rational number. It is not a irrational number, right? The square root of, they asked here, the square root of a positive integer is a irrational. The square root of a 4 is equal to 2. 2 is a rational number. So it is not. Write down here. The square roots of positive integers are not irrational. For example, the square root of 4 is equal to 2, where 2 is a rational number. Is it clear? The square root of a 4 is equal to 2 is a rational number. They asked the square root of a number is a irrational, but here is a rational. So the square root of a positive integer are not a irrational, they are a rational. Well students, the last question is, show how root root 5 can be represented on a number line. So before representing root 5, we can represent root 2 and root 3 on a number line. After that we will discuss root 5, right? So first one we can draw root 2. So root 2 means here we want to draw one number line, right? So here is a 0, 1, 2, 3. So here minus 1, minus 2, minus 3. So on. There goes, right? So when we want to draw root 2, so here we want to take 1 unit distance from a 0 to positive direction of the number line. So 0 to positive direction of a number line. Here we want to take 1 unit length. So I will take here 1 unit length is this much, right? So after that, here we want to draw one perpendicular line that is also 1 unit. So here I will draw one perpendicular line. It is also 1 unit, right? So now it is a right angle triangle. When we joined this line to the center, it is a right angle triangle. So this right angle triangle hypotenuse is a root 2. So how it means, give a name here. Here O, here A, B. So using Pythagoras theorem, we will know that OB square is equal to OA square plus AB square. So it is a Pythagoras theorem, right? So we want to find out the distance of a OB, how much, right? So AO is a 1 unit, right? We will take 1 unit square, and plus here also 1 unit square. So 1 square is 1, 1 square is 1. So 2, right? So here OB square is equal to 2. Then the OB is equal to square root of 2. So OB is a root 2. Is it clear? So now with the help of divider, we will take this much distance. So using divider, we will take this much distance and then cut the number line. So this distance cut the number line with the help of divider. So here we will cut it, right? So it is our root 2. Then this much distance is called a root 2. Any doubt? So once again I will explain here. So first draw a one number line. After that, take 1 unit length from 0 to the positive direction of a number line. So here to 1 unit. After that, here take one perpendicular line that length must be also 1 unit. So here we will frame one right angle triangle. The right angle triangle hypotenuse is a root 2. So here is how it is a root 2 by Pythagoras theorem. So it is a root 2. So using divider, take this much distance, the OB distance and cut the number line. So that is the root 2. Is it clear? So next we will draw root 3 on a number line. So root 3, we have to draw root 3. It means before we want to draw root 2. Using that root 2, we will draw root 3. So here is a root 2, right? So this distance here is a root 2. So here we want to draw 1 unit perpendicular line. 1 unit perpendicular. So otherwise, first draw a number line and take root 2 unit from the 0 to the positive direction of a number line. Otherwise, first we will draw to root 2, and after that draw here one perpendicular line. That length is also 1 unit. So then join to the here center point, O point. So this distance here we will give name C. So OC is the hypotenuse of the right angle triangle. That is also root 3. So see here, OC square is equal to, here we will give name D. OD square plus DC square, right? So OD is a root 2 whole square plus OD is a 1 unit. We will consider as a 1 unit. So root 2 square is a 2 plus 1 square is a 1 is equal to 3. So OC square is equal to 3. Then OC is equal to root 3. right? So this much distance is a root 3. By help of a divider, we will take this distance and cut the number line. So here is a root 3. So before 2 will comes that one, right? Root 5. So here first we want to draw one number line, right? So here is a number line 0, 1, 2, 3. So here -1, -2, -3. Then take a 2 unit length from the 0 to the positive direction of a number line. So I will take 2 unit length. So it is the 2 unit length, and draw here 1 unit perpendicular line. 1 unit perpendicular line and join these two. So here we framed one right angle triangle. In the right angle triangle, hypotenuse is a root 5. So give the name here O A B, right? So draw it. So what is the Pythagoras theorem? OB square is equal to OA square plus AB square. So OA is a 2 unit, right? So 2 square plus AB is a 1 unit, 1 square. So 4 plus 1. So 5. OB square is equal to 5, then OB is equal to root 5, right? So here OB is a root 5. So the help of divider, we will take this much distance and cut the number line. So here is a root 5. Any doubt? So